at the minute I've got 2D curves there and MS draft surfaces, so I'm going to project those onto there. See, the curvature does something very interesting when you go like that. That's the curvature. I think it's because it goes completely flat in the middle and it does something weird from that particular view. Not to worry. Yeah, so this curve goes across the center line. So when we project it, we also want to keep that so it's completely going across the center line and symmetric. So to do that, I need to extend these edges. So if I go into extend, which is under here, there is an actual option which I think will do the job. So we've got the extrapolate and merge on, which basically means it creates one surface. If I take merge off, we create another surface, but I want it as one surface. But you've also got percentage. So if I put in a percentage of 100%, I think it will be. Let's just see if I'm right. Yeah, it doubles the length of it, so it adds 100% to it. Equally, if I wanted to halve it, then I can put in 50% instead. But I want to double that. I might as well double those. I mean, there's no purpose in doing that. It just makes it look neat and tidy, that's all. Okay, so curves 5 we're in, these curves here. So I'm now going to project those curves on. Don't really need to see the CVs of those surfaces particularly. And also we don't really need to see these planes, to be honest, at the minute. So I can switch those off. So project. Now with project, what I want to do, I've got nice CVs on there that I like. And so I want to create a curve on here, not a curve on surface, an actual curve, just like this. And I want to match the original CVs. And I do want to do this in the Z direction. So let's just open this menu out a bit. I can put create history on, which I'm going to do. And so let's just try that. So select the surface and then select that curve and project in the Z direction. And it tells me, very helpfully, that the deviation is 0.482. Now, if I rotate that view, you can see it's created that curve. I mean, the fact that there's an error probably doesn't matter, to be honest, because it's a combination of a curve and a surface, so we wouldn't expect that to be 100%. If that surface was flat, we'd expect that to be 0, that we wouldn't have a deviation at all. But because it's not flat, we expect that not to quite sit on the surface. It sort of doesn't matter because we're making all of this up anyway, and we're just going to eventually, these surfaces are just for construction, and we're going to throw them away. But if I wanted to make that more accurate, I've got history on. So what that means is if I go back to this original curve and update it or change it, so if I increase the degree to 4, for example, it now says 0.001, which is great because that's as accurate as we need to be, really. So by changing the degree of this surface, this curve, it's updated the projected curve, which is very useful. And it means we've got a very accurate result. I mean, if we had to increase the degree to 7 and get that result, then I'd say, well, we won't do that. We just accept the fact that that's a little bit off that surface, because that surface is, we've only judged it from eyeballing it in the side view. So there's no reason that surface should be exactly where it is. So if this changes a bit, it doesn't really matter. So let's have a look again at the next one. So we've got a curve in here. Actually, I got rid of the one, didn't I? I got rid of that curve that came out here because we didn't really need that. Now this is degree 7, so this should have no problem projecting, I would imagine. So let's try that. So I can take it out of the view slightly so we can see it better. And the result is 0.001, so that's fine. And because we trim these curves back to these edges here, we know that should end exactly on that edge. I mean, it's always worth checking when we come to that point, but pretty certain that point is on that edge. That's what it should be. So the same again with this one. This one's another high degree. But because this has got a lot of shape in it, and this has got a lot of shape in it, you can see that's not as accurate. 0.259 it says. Let's have a look at that. So it does something very strange with the CVs, and it's because it has to do that to get around that shape. One possibility there, I mean, if we said that it's got to be 0.001, then we'd have to split this curve up probably. But there are other things we could try and do. I mean, one, because that's only a small distance, my thinking is that actually that's close enough, and that we should just work with that curve and forget about this construction services. They were just there to give us a start, really. So I think I'm going to ignore that one. And this one, hopefully, this one should be pretty small. Yeah, it's absolutely microscopic. It says 0, which is good enough. And that's because we've got a fairly simple surface there. It's only degree 3, so you know, combining that with a high degree curve there, which could probably be lower, to be honest. Let's just try that. Let's see if we change the degree down a bit of that. I don't quite know how I ended up with that as degree 7, because that seems like very high, but as long as it doesn't change the shape substantially. So yeah, so we get to 3 and it says 0.042, the difference. I mean, that would be perfectly acceptable again, because there's no reason that it has to be exactly on that surface at all. So I think I'm just going to accept that. Keeps it, you know, the simpler we can make things, the better. So this curve 0.5, I'm now going to rename as, I'll call it, it's not really glass house, it's, I'll just call it curves top 2D. And then the curves that we've projected, if we wanted to, let me just create another layer, just call that curves top 3D, or projected or something, and assign that to that. And then we'll get rid of those curves and we change the color. Like I said, I like the green color of the curves usually, because it's just so easy to see against everything else. Now these surfaces here, they were under con or construction. Don't really need those now, because we can now work on these actual 3D curves. I mean, we could have gone straight to creating the 3D curves if we like. It wouldn't really have made much difference, to be honest, especially as I'm going to change these a bit anyway. So looking at these, obviously these CVs look all over the place anyway. And we want to make sure these are aligned as well. So let's just align those. So I'm just going to do them in G2. See what that gives us. So that's obviously going to move it somewhat. I've got create history on, so I can change this curve here if I wanted to, and I'm going to move these points up and down. So this one, I don't like that. You know, the pattern of CVs ought to follow the shape that we're trying to create. So if you took away the curve, would you be able to see what the shape is? And with CVs that look like that, you wouldn't be able to tell. You'd think it might dip down and rise up and do all sorts of funny things. So I want to bring that right down so it's actually looks like similar shape there, and then raise that one up. Now that's going to go away from the shape that we've got. This one we could bring down. Obviously that does need aligning as well. So which way around should we do that? We should align this into there, really. Usually, you know, if that was 2D, we'd say align that into there, because that's the blend around the corner. So that's the way I'm going to do it. It sort of doesn't matter, because in a sense, because you can do it either way. So that hasn't changed it in that view, and it has changed it in that view, but this brought it up there. So let's just go and pick that point, and I suspect that this point will come down as we do it. So we'll get both of them doing the sort of thing that we want to do. Now this has gone off the shape a bit here. If we zoom in far enough, we can see that point is actually dropped below the data, and so we can raise that up. We've got to raise that one up because this is the one that's aligned. If we try and raise the other one, it's not going to want to move. And then so we get that more on the data, and then this one needs to go up so that it follows the tangent more. in this area, and then we'll have to modify that one as well. So you can go on, you know, for a long time trying to get this absolutely 100% perfect, but we're interpreting the data rather than trying to copy it completely, because we know that it may not be completely smooth. Now this looks all okay in that view. I've kept that deliberately oversized. You know, you could trim it back to this point, and maybe I will in time, but actually we can do that in the surfaces. So let's just have a look at that. So that looks okay in terms of where the data is. The other thing we want to do is actually just rotate the whole shape around, because sometimes you find that in the views it looks fine, but when you rotate it around, you may find areas where you think, well, that should be, you know, it'll have some strange wobble in it. I mean, the only area I can see where it sort of looks like it drifts off a bit there. Now we're zooming in and we're looking along it. You know, the data looks very straight in there, and we're quite rounded, and so we might want to change that a little bit. So you sometimes have to work on these things in 3D. So let me just try and I'll just increase the mouse sensitivity a bit. Now this is aligned to that. So if I try and change that in the Y direction, okay, sorry, that is the fourth point, so we're okay with that one. It's this one I won't be able to change, so it doesn't want to change in the Y direction because it's aligned to here, so it's completely determined by that curve there. So if I want to move that one outboard, I'm going to have to do some change to the curve at the back. So first of all, hang on a minute, which way did I do that? Let's cue that. Okay, it's still got projection control on there. So I actually want to delete the construction on that curve. I think if I've done this right, yeah. So we're still aligned to there. So let's just. So what we want to do, this is curving round too much, so we need to flatten it off a little bit. So if we pull that point there out in the Y direction, that'll help flatten it, but at the same time we want to change the tangency there a bit. Compare it with data. Pull that out a bit. So I'm looking at this point here, and then we'll pull that point as well. And you could also pull this point to try and flatten it. So I'm looking at what's happening here, but of course I've also got to look at what's happening here. So you might want to pull that back out a bit. I'm sure this is all going to change again and again and again as we develop the surfaces and things. So this seems to go a little bit inboard there, so maybe that should come out a bit. Something like that. So it was mainly the shape there that was just very essy compared with the original. So I'm just going to leave it like that, because as I say, this is going to change, I'm sure, as we develop the surfaces. Let me just save this. And we want to bring in our surfaces that we developed here. Now I can't remember, but I don't know whether I had history on those. You see the intersect there, that was the intersect between that and our construction surfaces. So what we need to do is make sure that there's a good relationship between that line and the green line there. It's not going to be an offset or anything like that. You know, if we were doing an A-class model, it might be that we'd have to make that a pure offset. But as long as it relates in some way, it sort of looks as though it does. Let's take that off. Yeah, it doesn't look as though it's not crossing over or anything nasty like that. And we're going to put a blend in on this corner as well. So I think that's okay. We're just going to go with that anyway. if there was, if we needed to, then we could put history on that intersect, modify this side surface if we wanted to, or we'd modify the curve, one of the two, or both of them, to get a closer relationship between the two. So I think the next thing we need to start looking at is the blend going around this corner. So we've got this blend curve here, and that's obviously, it needs to relate to that. So we might as well use that and copy it. And so if I do Control C, Control V on that and just move it across here, and then we want to use the same curve on this intersect here. So let's put pivot point on there and just move it. We'll move it to that point there. And of course, it's not going to join up with this curve here, but we can just do a non-proportional scale on that. Could be one option. So we get it to about that point there, which looks really as though it's going to fit nicely. And then we can align that in both directions, both ends. So we'll just do a G2 alignment there. G2 there. And that looks okay. So we'll now, I think what I'll do is I'll put that onto this layer, although it's a curve, just so we can get rid of that and work on this top surface here. And we've got our mesh in here, so we need the glass area, glass house, to just compare this against. Actually, we could bring in our con surface there, and I'm just trying to think whether we can get an intersect. Well, I won't bother with that. I was just wondering whether I can get an intersect between the mesh and the surface, and I suspect it's in here somewhere. One of the mesh functions, I'm sure, but mesh project, mesh intersect, never used this before. Select meshes or surface to intersect. So I suspect that we have to pick the mesh first. So that one and that one. And then the surface. Okay, so there's our intersect between the two, compared with our curve. Let's bring that projected curve back in. So it's saying that on the mesh, it's slightly inboard of where we are. So we should modify that. I pick all of those objects and just take the CVs off so we can see that clearly. And then we just move that around a bit, just so it's a bit closer to where it should be on the mesh. And we're also looking, not just at that intersect, but how does it relate to this curve? And it does. It still looks as though it's relating to it in the sense that, it's tapering all the way from this end to that end. We haven't got it doing something like that where it's clearly going too far inboard. It actually follows it still, so that's fine. Let's get rid of that curve. And I'm not sure what that object is. Whether it's it is actually that intersect is actually a curve. So we can delete that. Oh, maybe it isn't a curve. What's that then? Maybe it's a curve on surface as well then. Oh, it's curve on surface as well. Sometimes I've never used that function before. So I think I've probably deleted the old intersect, to be honest. Never mind. Get rid of it all anyway. It's not really relevant. Now, if we look at let's have a look at some sections here. So we don't want this construction surface on anymore. Let's put some sections on. Of course, this curve that we've got is sort of halfway up the surface, so it's actually not exactly where we want it to be honest, but it gives us a guide as to where we should want to go. Interestingly, Let's have a look at that curve. Yeah, that curve, well, that's just a stroke of luck. That curve, which actually is curved in that view, is so close to that Z section that we could almost say it is on the Z section. And so that's actually quite useful to have that. Let's put the X sections on as well. Let's just go into here, and I'll just take the surfaces off. So you can see that this is quite a tight fillet here, and then it gradually grows out quite quickly into that big blend. So that we're going to try and go from this shape here down to this point here, which is going to be interesting because we've got to try and make that reasonably close to the data, which is going to be quite a challenge, I think. Now what we could do is start with the simpler bit, which is to put a fillet in here. So we'll take the Z sections off, it's just too much. So I'm going to put in a fillet down this bit between these two surfaces as a starting point. So I'm going to go into surface fillet, and we want, there's an awful lot of options in here. The section type we want is we're going to make it G2. Construction type, what this means is if I said radius, and this is a simpler way to think about it, if I say radius and G1 circular, and we put in a radius, and we don't want this, but I'm just going to try and show you what's happening here. So let's go and make that a radius of 50 mil, for example. At the start of the fillet, we're going to have edge align. At the end of the fillet, we're going to have edge align. So we go from here to here, and you can see the arrows showing this the normal directions that it thinks it's going to be using, and you get that. Let's make that a bit bigger so it's easier to see. So I'm not trying to get a result here, I'm just trying to show you what's going on. And we'll put history on so we can go back and forth to this. So with this one, I've just said G1 circular radius 300, and it should come as no surprise if I go and pick the fillet. Let's get rid of the CVs off these so they don't confuse us. So if I go and pick that fillet there, and put curvature on with minimum on and maximum on for that matter. Let's change it down. You can see the radius is pretty much 300, which is no surprise, but it is a radius. It's a circle, which is not what we want. But what that does, when we say construction type radius, that's actually setting up the edges. So it's setting up that edge and that edge, as if we had a circular fillet in there. If we change the section type, and if you watch those edges carefully, if I change that to G2, you'll see the edges stay where they are. No, they don't. That's because I've got a completely different setup on here, because I need that to be, actually, do I need, no, maybe I'm talking nonsense. That 300. Yeah, let's try that again. No, that didn't work either. Okay, G2, center radius. Okay. Offset. Center radius. Center radius is 300 there. Doesn't work that way, does it? Okay, I'm talking nonsense then. I think I'm thinking of ISOMSurf, to be honest. But what you notice is that the edges of this fillet here is actually tapering, because we specified radius rather than if we specify caudal. So if I specify caudal and I put in a caudal length of 300, then you see the edge there and the edge there are parallel to each other, and they're 300 mil apart. So if I change that, if we change the type, then the edges stay where they are in that case. Now what we want is G2 curvature on the edges. So if we put our continuity check on, we should have G2 curvature. Sometimes you might find it fails, and that's just because it's doing it, as best it can. You can, if I see that error there and everything else is green, I would say we'll just fix that afterwards. We just align that afterwards if we wanted to. The other thing you can do is you can say explicit control if you wanted to, and then you can increase the degree. So at the moment we've got degree 1 down there. If I make that higher degree, then we can play around with these numbers and the spans, of course. So if I take that up to 7 and it's still not aligning, which won't be a surprise because it needed 3 spans before, and then we can change the spans to whatever we want it to be. So if you wanted to reduce the spans, well, 3 of those are curvature aligned. This one isn't. There's a good chance we could probably align that afterwards. So that would be an option. The other thing that has an effect, if I take explicit control off, is if I said single surface, so it tries to do that. You see it says degree 5, 10 spans, which is excessive, but it's trying to do it in one NURBS surface there. Usually you want multiple surfaces to get the accuracy, put multiple surfaces on and Bezier on. If I take Bezier off, you might get a slightly different result. So you've got, it still says it's 5 degrees and 10 spans. It's actually given us one surface, but this is usually the best one. It's given us only 3 surfaces and they are only degree 5 actually. That sort of suggests that, maybe if we went into explicit control, although I think I just tried this, and put in degree 7 going along that way and make this 3 spans, you'd think that maybe that would work better. But you can only do it by trial. In fact, it hasn't made any difference. That's still failing there. So I would just go with, and a lot of the time I just go with whatever it comes up with. As long as you've got multiple surfaces and Bezier on, it usually gives you a pretty good result. Now, what we need to do here is to get this to be closer to the data. I noticed that, on our section here, on the blue section, that we are slightly high on the data there, and I think that's just come about because it gave us better highlights. So we've got to take that into account. So what we're looking for really is to try and get that sort of tightness of where the brown section is in that corner there. So I think in this case, I've got caudal on, and so I've put arc caudal up there. If I go for radius, it gives me this tapered result, and I think actually in this case that's probably better because when we come down here it's got to be even smaller, and so that actually looks quite good. And as I say, it's got G2 curvature. Although it says radius, it's a bit confusing because it says radius, but it says G2 curvature. But radius is just determining where these edges are, basically. It's saying as if we put in a fillet with only radius, then if you imagine a ball sitting between that surface and that surface, that if you rolled it down between those 2 surfaces, that's where that ball would touch if the radius doesn't change. So that's what radius means there. It's slightly confusing, but that's what it does. It controls the edges. So I think this isn't tight enough here. We've got this thing called form factor, which for some reason is on 1.5. I put it on, normally I have it on 1, because it gives us some more, well, it just gives us more uniform spacing of the CVs there. It's still very round, this thing, and I think it needs to be tighter. So I'm going to reduce this center radius here down to 200, say. So that'll make the whole thing tighter. Again, we're not on we're not exactly on the data, the original data here or here, so we're not going to actually hit the same point, but it's just the character of that shape. I think it's actually probably tighter than that, maybe 150, something like that. It's you know, it's anybody's guess what that should be exactly, but I think that's close enough to what we want. So let's go with that. Something else, I had history on there, which is at this point is really useful because I can go backwards and forwards and change that if I need to. The other thing you notice, I've got edge align on, which means that, so edge align means that that end, the CVs are exactly on that corner, and the same on here, they go right to the edge, and therefore what that means is that we can trim these surfaces back automatically, which is what I've got here. So I've got automatic trimming. If you don't want automatic trimming, you can just say curves on surface, and so you keep the original surfaces there, but you've got the curve on surface if you wanted to trim to it. Or if you don't want the curves on surface at all, you can say off, so it doesn't put curve on surface on, but then of course you don't see the continuity checker. But here, because we've got edge align on both ends, we can have automatic on. If it didn't get to the end, of course automatic's not going to work. It just it'll put the curves on surface there, but nothing else. Now we need to get from here down to here, which is going to be interesting. And we can do it within the fillet function, or we can do something rough within the fillet function, so it might be worth a try, but probably is not going to work very well. So if I do use the same parameters that we've got up here, and that's going to struggle big time, especially around here, because I've got edge align on and those edges don't actually join up. Then it does something a bit weird with the end, because it's trying to join from here and flow through here. We could change that edge align to something else. I'm doing it on the screen, but actually it's usually quicker in here. So that's just connecting those points. So that gives us a slightly better result in terms of the surfaces there. But of course we want this huge section here, not what we've got here. Now you can go into, you could do a variable fillet. So if you click on variable fillet, I'm not suggesting this is going to work. This is just to show you what you can try. So variable fillet, it's not brilliant. So starting off with the same parameters at this end, but here, if we zoom right in, you sort of click on the end of that shape there, and you can see it's now highlighted here. I will take auto update off because you can see it's so slow with this, because it's very complicated. So let's take auto update. So having clicked on that and highlighted that end, we can then hopefully increase the size of it. Can you see the numbers changing at the bottom there? And I'll just keep on increasing the size of it. I don't know where to, but I'm trying. It's going to be enormous, actually. It's going to be huge, isn't it? Because we need to get that far. So this is definitely not going to work very well, but it's worth a try just to see what the system gives you. And the other thing is it's just taking the sort of tangency from that point. Hence, it doesn't actually join up with the surface at all, but it's just giving us an indication. So I've gone to that huge value there. So now when I press, I can either hit auto update or just press update, and it probably won't like it at all. Yeah, didn't like it at all. It's decided not to even bother. Let's take auto update off again, just to show you. If I made that a bit more sensible, maybe something like that, and then I'll put auto update on again, so it should update that. It seems to be thinking this time, but it's probably going to, yeah, so it's given us a variable fillet of some sort, but it's totally crazy. I don't know what it's doing down here. It seems to have gone into the other one. So let's undo all. I think I don't know why it's picked up on that. Maybe obviously I made a mistake somewhere there. But so let's just do that one again. And we'll do edge align on that one. And we'll take variable fillets off on that one. I think probably I didn't hit next. I just carried on doing this one. That's why it's probably struggling so much. So that was really not useful, because we're trying to go from this shape to this shape. It's just too dramatic. I think this is going to be difficult anyway to get a nice transition, I think, between the two. We might have to open this up as well. But in this situation, we often want to do a manual type fillet. So one option is we've got this thing called symmetric fillet. I don't know why it's called symmetric fillet, because it's not symmetric, but it takes one edge. So if we put in a curve, say from here to here, curve on surface, then we can actually fillet between that and the other surface. So let me just show that one. Like I say, this isn't actually in the right spot really. It should be further down here. I suppose we could move that down there, but it sort of doesn't matter too much. So let me just go from here to here with a curve. I'm just going to save this. And we'll look at that in side view. I think we should just get rid of that surface. It's only a mirror of the other one, so we can get it back easily. Oh, I still had my curve selected there, which wasn't a good idea. And so I'm breaking my rule of making curves green. I've just got it in that top layer. So let's make that degree 3, and then we'll align that G2 into here. I've got one arrow there, so I know it's right on the end, but if in doubt, just push it towards the that edge there. So it's a very, very dramatic shape. No idea what this should really be. Let's make that degree 4, so we've got a bit more control if we needed it. You know, maybe I'll bring that point down a little bit. I don't know. Until we put the surface in, we can't really tell what shape that should be, I think. So that's our curve, which we've just done in 2D, and then we can do a project of that, and it's going to be a curve on surface in the Y direction. So onto that surface there, and we've got it in Y there. So there's our curve on surface. That's the one we want. I'll keep that curve there, but maybe I'll just hide it for the time being. So it does actually look, now I'm looking at the sections, as if this holds on for much longer than I've got there, but it doesn't matter. We're just going to put something in. So let's go into our surfaces, and then we're going to go, and this is another function that I think is going to really struggle with this, but worth a try. So we'll make it G2, and we're going to see what happens basically. So I'm going to go from here. So that's the curve on surface that we're using. We accept that, and then it says select second set of surfaces, so this one here, and we just see what that gives us. Actually, it wasn't as bad as I thought it might be. It's not too bad, but of course it's nowhere near where we want it to be, which is the problem. Now this is our end here, so we've got end default, so it's just going straight across. Let's see what happens if we did edge align here. I don't know whether it will do anything. No, it doesn't do anything, because it's just got too far to go, and it's not even down to this point here. This one could definitely be edge align, because we need that to be edge align, so it will join up with the other surface there, or fillet there. It's actually not too far off. I mean, it's you know, it probably needs to be a bit tighter there, so maybe this could be a bit further here. Maybe we could make that curve a little shorter or something. We'll change the shape of it in some way. But it's not too bad, considering. It gives us an idea of where the other edge is going to be. That's really the important thing here. So it may not be very useful in itself, but it shows us where the system would like to put that other edge to make it. I mean, they call it symmetric, and I suppose they're talking about symmetry around the intersect at this distance here is pretty much the same as that. So that's where the symmetric bit comes in. But if I take the trim type off completely, so we don't create curves on surface, interestingly, we still got we still got the continuity there, which says only P, but never mind. If I try and pick curve on surface here, there shouldn't be one. No, because I've taken that off in the menu. But interestingly, it's got the continuity on there still. Don't actually need that. Not interested. It doesn't matter. But this gives us an idea of where that edge, where the system thinks that edge should be. Obviously not where we necessarily want it. So the only solution to this is to do the whole thing manually. So I'm going to put in another curve from here to this end, and we'll again increase the degree to 3 as a starting point, and then align that to there. I didn't mean to open the menu there. Again, that the little arrow there just means that we're right on the end there, which is what we want. Let's make that degree 4. Now we are very much inside where the system wanted that edge to be. So I think we will need to change the shape of this curve quite a bit. It doesn't need to be exactly on what the system thinks we should have, but I'll take create history off as well, and then we can get rid of the CVs on there. So that's just for a bit of a reference. Now the other thing is, I said that this curve needs to be right down here really and join up here. We've got no way of judging where that should be. We're going to have to just compare our fillet eventually with the curve that we've got here, see that we're reasonably close to it. Let me just pull this over this way a bit. So we're not going to get to that edge, because that edge isn't actually very good anyway. It's sort of S's. So at most, really, we probably want to get it pretty flat here, and then we can extend this out as well. So we'll extend it to that point there, and then we can project that. I'll project it as a curve. And the reason I project it as a curve is because if I build a surface from curves rather than curves on surface, you usually get a better result. But of course it will at some point need aligning to these surfaces. So this is a challenge, because this is quite an extreme shape. So I'm going to do that. Curves match original. So in other words, keep the curves on the CVs where they are. Difference between that and the theoretical, perfect projection is only 0.3 of a mil, which is quite a surprise to me, and that's good news, really. Now we've got history on there, so we've got this one is our 2D version. It's degree 5. We could increase that to degree 6 and just see what the deviation is. So it's now 0.0 something. It doesn't have to be 100%. It's just because we're roughing things in here, so that's more than close enough. We can actually get rid of this one now. We don't need the original. We just want that one that's projected, even though it's a bit rough. It's sort of projected onto that surface there. We should look at it in 3D and just see if that's a reasonable shape. It seems to be okay. It's not. It sort of S's around a bit, but then we're dealing with very organic shapes here anyway, so that's fine. Now I think I've lost my curve there, or maybe I just, oh right, that's what I did with it. So on this side, I'm going to get rid of the curve on surface that we projected on, and I'm just going to project that curve on to this side. But first of all, I'll extend it so that when we look at it from the side, it's going over the edge there. So we've then got the projected curve will end at this point. So let's project that in the Y direction. And again, we are surprisingly close, 0.27 of a mil difference. And but if we want that better, because I've got history in that project function, I can then go and change the original degree. Let's just make it 5, and now we're down to 0.038 deviation, which is more than enough for the time being. So we get rid of this one. So we've now got 2 curves in there. I'm going to save this because I want to lose these curves, that's for sure. And that was about 10 minutes as well. And so we're going to use these curves as the basis of our surface. We're going to get rid of this fillet that we created, because that was just to sort of see roughly where that other edge might be, but didn't mean we had to follow it exactly, something like that. Right, so now we want to get a surface in here, and I'm probably just going to use square, which means we need 4 edges. So we've got this edge, and that edge, but we need another edge here. So I'm going to take the curve that we've got here, I'm going to copy that, Control C, Control V. I'm going to move it down to the end here, and we can then stretch that to the right position. You know, you can do so much with non-proportional scale. That's what we did before. That's perfectly fine. But there's also this function called stretch. So if we go into where is it? Here we go. Curve edit stretch. So we've got stretch there, and we go press go. Pick on the copy, which is that one. So it's the one I've attached to this end, and then we've got these handles on. So you can go and pick that end there and just move it around, or we can go and snap it to this end point here. And so now we've got it stretched between that point and that point there. Now let's have a look at that in side view, see where that curve is. It's pretty much, or it's almost on a plane. So if we were to align that into there and align that into this edge, that should be pretty close to where we want it to be. Again, it doesn't, none of this matters, that we don't have to get this absolutely perfect. The main thing is that we need that point to be exactly on the end of that curve, and that one to be exactly on the end of that curve, and then the square function will work. So if I align that there, it's changing the angle quite a bit, you notice. So I want to put some blending on. So we've got degree 7, and we're only doing G2, so we should be able to get those 2 points there in the middle. And I've got a blend factor of 1 on, which is what you want to do when you're blending from one end to another like this. Now I haven't got create history on, and that means I can also do a blend from this end and affect these 2 points. If I put history on, then it would stop me doing that from the other end. It may not make much difference, to be honest, but if I go into that end and align that to this edge, and we go top, so with blend on, it's affecting those 2 points. The difference is probably very, very small between that and not having the blend on, and it's sort of, we're fussing really, because I mean this is so far down here, we don't know whether this surface is actually going to give us what we want at all anyway. So now I want to put in a square between those that edge and these curves here. So let's go into surface, square, and all of these are just going to be G0. I mean, if you've only got curves, that's all it can be. Or having said that, of course, we have got continuity into this end of this fillet, so we could make that G2. So let's put that one as our first one. So you've got to decide which way round you're going to do this when you pick it. So I'm just going to pick from there, that one, and that one. So one of the things you might find in this menu is you try and do this, and it says the corners aren't connected close enough, and sometimes it's a ridiculous tolerance it's looking for, and you just have to, you just got to make sure those are attached properly. That's why I made sure that we stretch this curve to that end point exactly, otherwise it won't like it. So actually the CVs down here look surprisingly okay. The CVs up here look pretty bad, but considering the shape of it, it's not too bad. I don't know whether if I go into the top view, because I've got G2 on there, it might be worth just trying G0, seeing if that helps the CVs. It doesn't at all. So let's put G2 on. The other thing that we can do here, if I go into continuity options, is it? No, it's collinear. Yeah, continuity options collinear. What this means, so we've got our, if you look on these edges, we've got boundary 1 in yellow, boundary 2, boundary 3 and 4 in the order in which we picked them, basically. And what we always want, if we're trying to get G2 there, we always want into an edge, the end of the fillet there, we always want this to be linear. In other words, the CVs will be in a straight line compared with this fillet here. So boundary 2 and boundary 3 don't actually matter. The fact that I've left those on, because we've only got position, it doesn't make any difference at all. But if you've got G2 or G1 or G3 in there, then you want that boundary, if it's into the end of the surface, to be linear here. The other thing that we can play around with, although it probably won't make much difference, are these values here, 1 to 3 boundary blends. So from here to here, you can try, will it improve the CVs? It does actually. Oh, that's pretty good actually. That's improved those CVs quite a lot at this end. So messing around with that. In fact, I've put it to the default, which is 0.5. This is from the other direction, 2 to 4. Let's make that 0.5 as well. That's the default. Usually that default's pretty good. But it sort of doesn't, again, we can mess around with that later on anyway. So let's go with that. One sort of, I think a little bit of a, it's not a mistake, but I think I could probably have got a better result if I'd taken that curve and then stretched it between these 2 points and tried to get the CVs similar. Because what this is, the reason this is sort of stretching like this is because I've got CVs on the curves which are quite different. I might just try doing that actually. Let's just get rid of that. So I've just saved it. So let's go into query edit and undo all. Let me just see if we can do that. So this curve here, I'll do Control C, Control V, and just move it in some direction. Put the pivot on that point and move that to this end here. And then we can use, again, curve, edit, stretch, pick that point there and move it down to here and go into the left view. Now, because it's stretch, it's going to be completely different. We can actually bring the whole thing down. If we say plus handles, it'll put a handle in somewhere along that curve. So we can, I don't want to really move it. I don't want to move it left and right particularly, but maybe move it down. It just allows us to get a bit closer to there. So this one here, this one we'll template this, and just trying to think where template is in the menus, but I've got it on Control T, I think. Yeah, so it just gives us as a reference there. Can't think off the top of my head where that is in the menus. Maybe it's in object edit or something, or pick. Oh, that's picking a template. Maybe display. Oh, here we go. There it is. Display template. So it's just a way of, rather than putting it in another layer and making a reference or something, you can just make it as a template. So you can see the grey behind there. It just means I've got something to refer back to. So I'm just going to move these CVs around. I mean, we made up that curve in the first place. It doesn't have to be exactly the same, but let's just make those a little bit closer to that shape. And then we can go and pick the template, which I have got in this menu, and just get rid of that. We don't need that. I haven't aligned that. In fact, that's one thing I should do. I should align that to there. Again, I'm looking for that arrow there. I've got blend on. That looks fine. It's a nice shape. And then I want to project that on. So surface edit, project, curves Y. So we're going to be on that surface there, that curve there, 0.029. So it's actually got closer somehow, and we'll get rid of that curve there. So hopefully this might give us a better result when we do the square. Let's have a look. So let's go square. It's because of the parameterization or the spacing of the CVs on that curve there is close to the parameterization of that curve. At least that's the theory. Let me do it again. So G2 curvature on boundary 1 and linear on boundary 1. Boundary 1 being this one. Do it in the same order that we did before. Doesn't actually matter which way around you do it, as long as it's like this. That hasn't actually made much difference at all, has it? But it was just it was worth a try. What you can do, what we could try here is so we've got edge 2 and edge 4. Edge 4 looks nice. This one sort of, I just feel all the CVs ought to come down this way a bit. We can actually rebuild that, so it takes more of the parameterization of the other side. And what has happened there? I don't think that's made it any better. It's actually increased the degree. If we put explicit control on, then we'll reduce the degree again, which would need to be 7. So that's really not helped at all. So I'm going to take that off and explicit control off and work with this. Now, one way of improving this, I think, will be to, because I just don't like the way the CVs go quite so extreme there. I think one way that we could do this to make this easier to cope with, because the trouble is, because the CVs come in at such an angle, that's usually a bad thing, because when we come to trying to align this to that surface, it's probably not going to work, and also very difficult to control the CVs if we want to make that the right shape. Now on this one, we've got degree 5. This surface that I've created is degree 7, because of this curve down here. It's just giving us an extra headache because we've got more CVs to cope with than we really want. So I'm going to make this degree 5 going across this way. So I will put explicit control on, and so I'm going to make that degree 5 going that way, and this one we can reduce maybe to degree 5 as well. So it's not going to be exactly on any of our curves at all, but it just means we've got far fewer CVs to deal with. Let's just take the CVs off the curves there. But I think what's going to hopefully help this surface is if we trimmed it or trim converted it in some way, so that we can, if we trim it more across this way, then those CVs should be better. So I'm going to divide it into 2 bits. It also helps us when it comes to aligning. So let's put in a curve here. Just trying to think how to do this. Doesn't really matter. Let me just put a curve from, say, there to there. And I don't want it a completely straight curve. Let's make it degree 2. So we do something like that. So at this end, we've got it, it's almost straight. At this end, it's curved. In the middle, it's sort of slightly curved. And let's just see what that does. So if I go into trim convert, and we want to divide this, so we're going to do a project this direction, and we then pick those sides, or pick one side and just say divide. So we've got now 2 surfaces. So this one's not it's not terrible, but the CVs are a bit messy. This one's not too bad, but at least the CVs are coming in more at 90 degrees to the edges, which is usually the best thing to do when you want to try and align things to each other. So the next thing we want to start to try and do here is to try and what we're going to try and do is get this surface aligned on both sides, both of those surfaces, CVs tidied up, and then we also want to measure the distance between that curve and the surfaces. So let's just, although it's not aligned either side, let's just see what that is, just out of curiosity. So if I pick that and I pick that surface, yeah, it's 16 mil at the minute, but because it's quite a big surface, that's not too bad, because we're trying to create something very large here to cover a big area. And there might be some tuning that we will do on the edges, but hopefully we're reasonably close to the data. Even now we're sort of heading in the right direction. It's not quite on the data, but when we align it, that will make a difference anyway to how that fits.